Today, we will study the heating and cooling curves. A heating curve shows the changes in temperature of a substance as heat is supplied. A cooling curve shows the changes in temperature as heat is removed. Heating curve, A to F, A to B. At point A, the temperature is 0 and the substance is in a solid state. Then the temperature rises from A to B. At point B, the solid starts melting. B to C. Point B is called the melting point of that solid because the solid starts melting at a constant temperature. Can see there is no change in temperature from B to C, C to D. At point C, all solid is converted into liquids. Further increase in temperature from C to D will also increase the internal energy of the liquid, due to which the liquid starts boiling at point D. D to E. At point D, the boiling point of that liquid. From D to E, no further increase in temperature, all the heat is provided. At this point is used to increase the internal energy of the liquid and weaken the cohesive force, by which all liquids start boiling. E to F. At point E, all the boiling liquid starts converting into vapors till point F, all liquid is converted to vapors/gas. Cooling curve, F to A. F to E. Gas cools, and its temperature decreases. E to D, gas condenses into liquid at a constant temperature, called the condensation point. D to C. Liquid cools, and its temperature decreases. C to B. Liquid freezes into a solid at a constant temperature called the freezing point. B to A. Solid cools, and its temperature decreases. Remember that during melting and boiling, the temperature remains constant. Heat energy is used to change the physical state of the substance. The melting point and freezing point are the same temperature. The boiling point and condensation point are the same temperature. The flat portions of the curve represent a change of state. Example: water ice heats up to 0 degrees Celsius. At 0 degrees Celsius, ice melts into water at constant temperature. Water heats up to 100 degrees Celsius. At 100 degrees Celsius, water boils into steam at constant temperature. During cooling, steam condenses at 100 degrees Celsius and water freezes at 0 degrees Celsius. Conclusion: heating and cooling curves help us understand the interconversion of physical states and show that temperature remains constant during a change of state while heat energy is absorbed or released.